Welcome to Spring LIB.
In this question there is a figure given, so first I will draw this figure and explain the data that is given. So in the figure you can see that there is a ground with surfaces that is hard, and on this ground there is a building given, that is height is also given, that is equal to capital H. Now in the question it is saying that there is a man which is having a bag, and also it is resting initially at this roof of given building. So consider that this is a man and this is a bag, and it is initially rest at the edge of this roof. Now in the question it is saying that the mass of man and bag is given, that is mass of man is equal to m, and mass of bag is given, that is equal to small m. So now in the question it is saying that the man is slipped down vertically. So you can see that here I will draw this dotted line which is showing the line of fall, and this line is a vertical and man is falling down vertically in this line. And consider that at this point where height from bottom is given, that is equal to small h. So at this time the man he realized that the ground is having hard surface, so it think about saving his life. So what he do is, he during this falling he also noticed that there is a pond, and distance between pond and this line of fall is given, that is equal to x. So x distance I can say that this is a pond. So this man think that if I throw the bag in horizontal direction, in opposite horizontal direction, then it will be possible to land up in this pond. So what he do is, he throw his bag. So now after throwing that, in the question it is saying that we have to find the minimum velocity of this bag, and after it we have to find the location of bag where it is landing on the ground. So we have to find this location of bag. So this is the question. Now let's start answering this question. So in the answer, first I will try to find minimum velocity of this bag, horizontal velocity of bag. So now here first I write the given data. So data is given, that is mass of bag, and man is given. So mass of man is, that is equal to, I can say that capital M, and mass of bag is, that is equal to small m. Now since this man is initially at rest at the edge of roof, so I can say that the initial velocity of man will be, that is equal to 0. Now after falling down, I can say that, let's assume that the man throw his bag towards left, that means with respect to himself it is throwing in opposite direction. So that means I can say that in this direction. So consider that the velocity is, that is after throwing towards left with a velocity of bag is, that is v1 and himself moves towards right with a velocity that is consider that is v2. So now next step is, after writing the velocity of bag and velocity of man at this point, when the height is from bottom, I can say that h height. So here I will apply a law of conservation of momentum. So according to this law, I can say that it will be written as, that is, mv1 is equal to capital M v2. So I can say that after simplifying I will get the equation of v1, that means velocity of bag, that will be written as, that is, mv2 over small m. So I can say that this is the equation number 1. Now next step is, I will try to find the time to covering this h small h height distance. So for finding this, let's assume that the total time it takes to reach the ground is, that is equal to t1, and I can say that the t1 will be written as, that is equal to, total height is given, that is from its initial point to bottom point. I can say that total height of, that is covering this distance, that is capital H. So the t1 will be written as, that is equal to square root of 2h over g. And now let's consider that total time it takes to reach the height small h will be, that is consider that is t2. So value of t2 will be written as, that is equal to square root of 2h, 2 times of parenthesis of h minus capital H minus small h over g. So that means here first I had find the time when it is completing the total height, that is capital H, and then after it I had find the time, that is t2, which is covering the distance, that is from a roof of line, line of roof. I can say that this distance, that is h minus small h. So covering this distance, the time will be written as, that is t2 is equal to square root of 2 times of multiplied by parenthesis of h capital H minus small h over g. So now next step is, I can say that after finding this, the time of flying in covering the remaining height will be written as, remaining height, that is h is equal to, that is equal to, I can say that t1 minus t2. So here next step is, put the value of t1 and t2 which I had get in the above previous step. So substitute this data in this line. So it will be written as, that is t1 minus t2, that will be equal to, that is I can say that the time of flying in covering the remaining height, that is h is equal to, I can say that time is, that is t, will be equal to t1 minus t2. So after substituting, the t will be written as, that is t1 is, that is square root of 2 h, capital H over g, then minus t2 will be, that is 2 times of parenthesis of capital H minus small h over g. So it will be written as, after simplifying, I can say that after taking a common, that is square root of 2 over g, then inside will be written as, that is in the parenthesis, I can say that square root of h minus square root of h, capital H minus small h. So now I can say that this is a equation number 2. Now next step is, after finding the time of flying in covering the remaining height, I can say that during this time the man cover a horizontal distance, that is x, because it is going to land in the pond. So I can say that the horizontal distance is given, that is in the question, that is x. So during this time the man is covering a horizontal distance, that is x, and land in the water. So x will be written as, that is x will be equal to v2 times of t. v2 will be, that is velocity of man. So I can say that v2 will be written as, after using this equation again simplify it, then v2 will be, that is x over t. So now next step is, write the equation number 1 here. So equation number 1 is, that is this equation. So I can say that v1 is equal to m over small m multiplied by x multiplied by, that is v1. So this is a equation number 1, sorry v2. So this is a equation number 1. Now next step is, here substitute the data of v2, value of v2. So by using this step, so I can say that it will be written as, that is v1 is equal to m over m, capital M over small m, times of v2 will be, that is x over t. So here put the value of v2, then I will get the v2 in equation number 1. Then I will get v1, that is equal to m over m, capital M over small m, times of x over t. So now next step is, here put the value of t by using this equation number 2. So I can say that the using this equation number 2, here I am substituting the value of time. So it will be written as, that is the value of time t. So I can say that the above equation, it will be written as, that is v1 will be equal to, that is capital M times of x divided by small m times of, now after replacing this t, it will be written as, that is square root of 2 over g multiplied by parenthesis of square root of h minus square capital H minus square root of capital H minus small h. So now I had get the value of v1, that is velocity of bag. So after getting this value, I can say that the minimum horizontal velocity of bag will be, that is V1 will be equal to capital M times of x divided by small m times of square root of 2 over g times of square root of h minus square root of h minus capital H minus small h. So this is the minimum horizontal velocity. Now next step is we have to find the location of bag where it is landing on the ground. So I will consider that bag lands at distance x towards left from actual line of fall. So and also you can say that there is no external force is acting in horizontal direction. The x coordinate of center of mass will remain same. So after getting this point I can say that it will be written as, that is use the formula for x coordinate of center of mass. So I can say that formula is, that is xcm is equal to m1 x1 plus m2 x2 divided by m1 plus m2. So here I can say that axiom will be, that is x coordinate of center of mass. So due to it is not changing its position, so that means the center of mass will be written as, that is axiom is equal to 0, and I can say that here m1 will be, that is mass of bag, that is given in the question, that is small m, and x1 will be, which we have to find out the location of bag. So and m2 will be, that is mass of man, that is given in the question, that is capital M, and x2 will be, that is horizontal distance between vertical line, that is line of fall, and the location where man is landing in the pond. So that means I can say that x distance, so x2 will be written as, that is x. So now after getting the value of all data, substitute here, so I will get the result, that is after substituting x, that is 0 will be axiom, that is 0 will be, that is small m times of x1 plus capital M times of x divided by small m plus capital M. So now simplify it, then I will get the location of bag, that is equal to x1 is equal to minus m over small m times of x. So now I can say that after getting this result, the bag will land at a distance of capital M divided by capital M times of x divided by small m, and direction will be opposite direction, that means towards left. So now you can see that I had get the minimum horizontal velocity, that is equal to this, that is equal to v1 is equal to capital M times of x divided by small m times of square root of 2 over g times of parenthesis of square root of capital H minus square root of capital H minus small h, and the location of this bag which is landing on the land is, that is distance will be written as, that is capital M times of small x over m, small m. So I had solved the question completely now. Thank you. Sorry, in this line I had forget to write, that is in this line, let the bag lands at a distance that is x1, because we have to find this x1 distance. So here I had taken a small mistake, so you include this point also in the solution. So that means I can say that the correct line is, that is, let the bag lands at the distance x1 towards left from actual line of fall. So now, after solving this solving this explanation which is I had written here, then I will get the value of x1. So I can say that the final conclusion is, after getting this value of x1, I can say that bag will land at a distance of x1, that is equal to m, capital M times of x over small m, and direction will be the opposite direction with respect to line of fall, so it means towards left. So this is the answer of given question. Thank you.